Our next speaker is Dr. Claire Wade, who is a senior geologist, metallogenic mapping. She works with the Geological Survey of South Australia, and after completing an honours degree in 2005 at Monash University, Claire commenced employment with the GSSA in 2006. She's been involved in regional geology and mapping projects with roles in mineral systems, footprints, and the 4D geodynamic and metallogenic evolution team. She's contributed in areas of geochemistry, isotope geochemistry and geologic evolution in South Australia. In 2021, Claire completed a PhD degree at the University of Adelaide, and her studies investigated the link between magmatism and mineralisation in Proterozoic mineral systems in the state. So her talk is entitled From the Craton to the Cretaceous, New Data from the Northern Gawler National Drilling Initiative. I'd like you to welcome to the stage Claire.
All right, thank you. And thanks for giving me the opportunity to share some of the work that we're currently doing in the Northern Gawler, and this will include some of the new results and data that we've collected from our drilling program. I'd first like to acknowledge the Antakrini Matu Yankunytjatjara people because the Northern Gawler drilling program is being undertaken on their land, and it was with the permission of the AMIAC survey team that we were actually able to conduct this program. So just a little bit of background to the National Drilling Initiative. So this is a collaborative project with MINEX CRC, which is a cooperative research centre that was established about 7 years ago. And it's a 10-year project, and when MINEX was first established, they developed this 10-year vision of what the National Drilling Initiative was going to achieve and some of the things that they wanted to get out of it. So one of these, what would we call it? Well, one of these things was, working towards a mapping Australia at a continental scale, characterising both the cover and the basement, and by doing that using the CT drilling that MINEX has developed. In conjunction with this is a number of analytical techniques and tools that are both being developed to use in conjunction with the drilling, as well as some of the analytical techniques for geochronology that Mitchell just mentioned. So the GSSA invested $5 million into MINEX, and this was for undertaking 2 drilling programs. The first one was the Delamerian project that we heard about some of the results from that from Tom. So that finished a couple of years ago, and the report for that is now available. So then that brings the next the question of what's next. So when we were thinking about the second area that we were going to conduct our drilling program, there were a few things that the GSSA wanted to take into consideration. So we wanted to utilise the CT 500 that MINEX developed. So this is the coil tube drilling technology, and the 500 denotes its 500 metre capacity of drill depth. So we were really looking at areas of less than 500 metres cover, ideally between 250 and 500 metres to get the optimal use of that CT rig. And we also were taking into consideration available areas, so looking at where there were wilderness or conservation areas, because we didn't particularly want to be drilling in those areas, and also places where active exploration was being undertaken. And we also wanted to build on some of the work that active exploration had been going on, and this includes some of the work by Petrotherm, BHP or Oz, and also Rio Tinto. We also considered things like which areas do we need to know more about the geology. So where are we going to get the best information to answer some of those big geological questions? And so that's what brought us to the Northern Gawler. So some of the questions that we want to address are things like the terrain correlations. So how does the Northern Gawler fit with the rest of the Gawler Craton, and how does it also correlate to some of the adjacent terrains? So we know that in some previous studies there have been correlations between the Northern Gawler and places like Mount Isa or the Arunta in the Aileron province. So really just to investigate what those broad-scale terrain links are and build on some of the momentum that's been happening in the area. In order to do this, we want to characterise what the basement rocks are and what their metamorphic history is. So looking at the different rock types, what the protolith ages are, what those metamorphic footprints look like, and also look at some of the magmatism occurring in the area. So by undertaking the drilling program in this area, we can fill in some of those gaps, both spatially and also geologically, and help provide some context for some of the younger events, such as the ones that Mitchell just spoke about. One of the other goals is to help refine the Arkaringa Basin. So we heard Bao Hong talk this morning about the paleochannel mapping that he's been conducting further to the south, and the basin prospectivity team will easily be able to extend some of those workflows north into our area and use our drilling samples to help refine those paleochannels as well. So we did hear about this younger copper mineralisation event, and so this is one of the things that we would also like to further investigate, is building on those ideas of this, I guess, post-1590 copper event. So we know that in the Eastern Gawler Craton, for example, most of the ICG mineralisation is around 1590, but some work that JU from University of Adelaide has done has shown that there is this younger copper event that's around 1500 to 1450. So really want to build on that and provide some context for that event. And also really look at what's driving it. So what's driving the metamorphism, the mineralisation and the magmatism associated with that younger event. So here we have a diagram showing the area of our section 15 up here in the Northern Gawler Craton in the Nawa domain. The relation of the Gawler Craton with some of the adjacent provinces that we're looking at those terrain correlations with, and the current solar geology map for this area. So we'll just have a bigger look at this map. So we can see there's not a lot of detail on the map. Most of it is dominated by this kind of greeny coloured unit that is attributed to being undifferentiated metasedimentary rocks. So we don't really know much about how old they are or what their lithologies are and what sort of history they preserve. We also have some Mesoproterozoic magmatic units scattered throughout here as well. So this is just a summary of some of the recent geochronology that's been undertaken in the last few years in this area, and most of this work has been done by Laura Morrissey and some of her PhD students. And so what we see is we do have a pre-Kimban record of magmatism and metamorphism, and then sort of these scattered, I guess, Sin-Kimban magmatism and metamorphic events, and then most of the history is dominated by the Mesoproterozoic metamorphism with some magmatism, including the younger 1450 magmatic or granites over at the Karkaroo 1. So we do have information in this area, but it's quite disparate. We don't really know how they all relate to each other. So what we want to try and do is help connect some of those dots and fill in some of the gaps. So as I mentioned, there has been previous work that has shown that there are links between the Northern Gawler Craton and some of the adjacent provinces. So here we have a simplified time-space diagram showing some of the main geological events in the Northern Gawler compared to some of these adjacent provinces. What we do see is that the Northern Gawler shares temporal and geological events with many of the provinces, but it doesn't share one single timeline with any of them. So it's really just how are we going to connect these dots, linking the history of the Northern Gawler with some of these other provinces. And so the way we're hoping to achieve this is through our national drilling program. So it was at Discovery Day last year that Tom Wise had the privilege to announce our Section 15 in this area, and we actually started drilling in October this year. So that was about a 10-month turnaround between announcing the Section 15 and getting the first drill holes started, which is an amazing effort from the team. So well done, everybody. So we've selected 12 drill holes in the area. And these are based on mostly on different geophysical characteristics. As Rashid mentioned before, there's not much outcrop in this area, so we're really relying on the geophysics to help generate those targets. And so looking at different, geophysical domains within the area. And so what we want to do is we'll be drilling through all the cover. Once we hit the basement, we'll drill for another 15 metres to ensure that we're in the fresh rock, and then collect a 3-metre core at the bottom in the basement rock. We'll use these samples to help characterise the basement, find out their protolith ages, and look at their metamorphic history. This is also in conjunction with the Discovery Mapping program. So we have Jack Percival, who's currently compiling the mapping in this area, and so we're sort of working in tandem. So the mapping's helping inform the drilling, and the drilling will help inform the mapping. As I've already mentioned, we're really exploring those terrain correlations, so hoping that by collecting this new data, we can help fill in some of those gaps and answer questions about how the Northern Gawler fits in with the Gawler Craton and some of the other provinces in the Northern Australia. One of our other goals is to look at the mineral potential in the area. So there's been a lot of work in terms of the ISCG space, but now we've got these ideas of those younger copper systems, so really try and build on those, and then potentially look at other commodities such as the rare earth elements and potentially base metals. So this is Jack's, first pass of the structural interpretation for the Northern Gawler. And we can see that there is a lot more detail compared to the previous solar geology. And what Jack has been able to do is tentatively pull out different times in which there was structural activity. So for example, we've got the red attributed shear zones, and then these sort of dark purple ones, with these dark purple ones being relatively older than these red ones. So we're hoping to try and answer some of those questions to see, when they were active, and really trying to unravel that history. So here I've got the locations of the 3 and 4 drill holes that we're currently drilling. So we've completed the ending 1 and ending 2, and we're currently up here at the moment. This is Jack's solar geology interpretation for the area as well, and you can see it's a lot more detailed from the previous solar geology image. Instead of 1 large big green unit, we now have 6, but that's okay. They're all based on different, mostly magnetic properties, so one of the things we want to do is really investigate, what the differences are between these units and these units. Are they actually different, or what's giving them those different geophysical characteristics? And one of the other things is looking at this extension of this Archean core that that has been highlighted in the mapping as well. So that's one of the goals for the drilling out here. So these are some of the results that we've got from the drill holes. So we've got the chip trays for the cover sequences from ending 1, 2 and 3. And what these show is a really nice cross-section of the Eromanga Basin at the top. So that's these units through here where we've got shales, mudstones, sandstones underlaid by another sandstone unit. These are most likely Bulldog Shale, underlain by the Cadanaoui or the Arkaringa sandstone, Algebuckner sandstone, sorry. And then this is underlain by the Permian Arkaringa Basin. So we're looking at a fairly consistent stratigraphy across the area, and so we'll be continuing to look at those relationships. These are our examples from core from the 2 completed drill holes that we drilled first, so ending 1 and ending 2. They're broadly both classified as biotite, quartz, feldspar gneisses, but one of the things that is really distinctive between them is the gneiss from ending 1 is an inversely magnetised metasedimentary rock, whereas the gneiss from ending 2 is a strongly magnetic metasedimentary rock. And this is actually really quite intriguing as to how this kind of responses happen. So that's something that we'll be investigating further. And so just to wrap up, so we're only about 3 drill holes into our proposed 12-hole program, so we'll be continuing drilling up until just before Christmas and then continuing next year, hopefully finishing in around end of January. And we'll be making sure that all of this data is available as soon as possible. We'll have a dashboard ready to include the preliminary logs, our PXF data as we collect it, as well as the survey data. As I mentioned, we're working in conjunction with the Discovery Mapping team, and so a lot of the work they've been doing is sampling the legacy drill holes to help get a regional idea of what the basement is. So we're currently working through geochronology and characterising those samples as well. And so, I guess the ultimate report, we'll have a final report that will include all of the detailed work, maybe the end of next year, but probably 2026. And thank you for your time.